This tutorial will take us through the steps for performing distance measurements. In this example, we want to visualize and quantify the distance between these nuclei. In order to do this, we need to make a binary image of the nuclei by creating a threshold, converting that to binary, separating any nuclei which have joined using process binary watershed. We're going to process binary options, and we need to change the EDM output to 16 bits. Click OK. And for the distance measurements to work, we also need to invert the image using edit invert. We can now go to process binary distance map. This produces a new image where the white areas are further away from the objects than the darker areas. For each pixel away from an object, the distance measurements adds one intensity value. We can use a lookup table such as the 16 colors lookup table to visualize this data, which you could save as an RGB file. But we can also quantify this. If we go to Analyze Set Measurements, we can select the mean gray value. We also want to select Limit to Thresholds and Display Label. Then we can go back and create a threshold on this image. Image, adjust, threshold. In this example, we want to threshold to the point where there are no blue pixels in the image, so just back to our originally thresholded nuclei. Don't click Apply. Go back to Analyze Measure. And this will give us a readout of the average distance in pixels between the objects. Even in calibrated images, this data output will be in pixels. We'll have to back calculate for calibrated distances. If you're not sure how to do this, you can find the calibration within your image, under Image, Properties, and it will define the pixel width and the unit of length, only in microns.